Alright, starting lesson 1.3, points, lines, and planes. Now, a point has no dimension. It is represented by a small dot and named using a capital letter. Alright, so point A. A line extends in one dimension and is always straight. Through any 2 points, there's exactly one line. So we got 2 points here, and through any 2 points, there's exactly one line. A line can be given a lowercase letter. You could refer to this line by a lowercase letter. Or it can also be defined by 2 points on the line. So we could call this, since these 2 points are on the line, we could call it line AB with the line symbol above it. Alright, a plane extends in 2 dimensions and is always flat. Through any 3 non-collinear points, there is exactly one plane. So here we have 3 points, and we're going to get to non-collinear in a moment, but non-collinear just means they don't lie on the same line. A plane can be named by a letter in the corner. All right, so here we have a letter in the corner that names the plane. Or you can also name the plane using 3 non-collinear points. So we have plane ABC. Alright, points are collinear if they lie on the same line. So D, E, and F lie on the same line, they're collinear. Points are non-collinear if they do not lie on the same line. So there's one line that runs through Y and X, there's one line that runs through X and Z, and there's one line that runs through Y and Z, but there's not one line that runs through all of them. Okay, points are coplanar if they lie on the same plane. Okay, so you want to imagine this to be like a flat surface, and you want to think about this surface as extending in every direction to infinity. Okay. So it's not just a shape, okay, because we can't draw infinity, but this is supposed to represent a flat surface going to infinity in all directions. Okay, now points A, B, and C are coplanar because they lie on the same plane. All right, then we have non-coplanar. All right, if they do not lie on the same plane. Alright, so here we have R, S, and T. They lie on the same plane, but U here is above the plane. Now it may be a little difficult to understand what's going on here just by looking at this diagram, but let me reorient this plane. Let me just flatten it out, and then just imagine that R, S, and T are on it. Now this isn't a correct representation, but this may give you a better idea of what's actually going on. Alright, and then you have U above it. So if you're looking at the plane from the side, if you look at the plane from the side, it's going to look like a line, all right? And you're going to have these points that are on the plane, and then you have U hovering above the plane, okay? All right, consider line AB, all right? Line AB, because it has a line symbol above it, we call it line AB. So here we have some examples. We have line AB or BA. It doesn't matter the order of the letters, it still describes the same line. Now a blank is a portion of a line, that would be a segment, is a portion of a line consisting of 2 endpoints. All right, so we have these 2 endpoints here. It stops at A and it also stops at B. And the order of the letters doesn't matter, but we have this segment symbol above. Notice that it doesn't have any arrowheads on it. And a ray is a portion of a line with 1 endpoint and extends to infinity in one direction. So here it starts at A, and it goes through B, and then it just keeps going. Since it starts at A, we start with the letter A. And then here we have the ray symbol, and it always points to the right. All right, here we have a ray where it starts at B, goes through A, and it keeps going to the left here. Since it starts at B, we start with B, and then here's the ray symbol above once again. Now, important, when naming an array, the first letter is the starting point. Don't forget that. All right, two or more geometric figures intersect. What's a more simple term for intersect? So you could say cross. All right, if they have one or more points in common. All right, so these two lines here, where they intersect? They intersect at E. All right, we could call this one line AB. We could call this one line CD. All right, here we have line K and plane M intersect at point A. So here we have our plane. Okay, and then here comes our line. It hits the plane. And now it shows the line dotted or dashed because it's what we can't see because it's behind the plane. And then it emerges from the bottom. Okay? But point A is that point of intersection. Now we have plane M and plane P intersect at AB. So you have this horizontal plane, and then you have this vertical plane, and they're intersecting at every one of these points here. Every one of these points just keeps going on forever and forever to infinity. But all these points together make a what? They make a line. All right? And so the 2 points on that line are A and B, so we could call it line AB. All right, let's get some practice working with some examples now to understand how all this comes together. All right, determine whether the given statement is true or false. S, P, and T are collinear. All right, so analyze the diagram. Are they collinear? That would be true. Points S, P, T, and V are non-coplanar. S, P, T, and V are non-coplanar. No, that's false. They lie on plane R. Points S, P, Q, and V. S, P, Q, and V are coplanar. No, that's false. They lie on different planes. Points S, P, and V are non-collinear. S, P, and V are non-collinear. That's true. Can't put those on the same line. Line N and line N. Line N and line M intersect at point P. That's true. Line PQ and plane R intersect at point S. That's false. Line M and plane R intersect at T. They don't just intersect at T, they intersect at all these points here. All right, this is line M. So the intersection of line M and plane R is essentially line M because they share all those points in common. All right, next example. Decide whether the statement is true or false. Points A, C, and E are collinear. A, C, and E are collinear. No, that's false. Points A, B, and C, and F are coplanar. A, B, C, and F are coplanar. Yeah, they lie on the vertical plane. That's true. Points E, C, and D are non-collinear. E, C, and D are non-collinear. No, that's false. They're on the same line. Points A, C, D, and F are coplanar. A, C, D, and F are coplanar. No, they do not lie on the same plane. That's false. Point A lies on CB. CB, point A lies on that line. Yeah, that's true. Point B lies on CA, or ray CA. Ray CA. Here we have ray CA. Point B does not lie on that ray. So that's false. Point F lies on plane P. Point F lies on plane P. No, that's false. Line AB and line K are the same line. That's true. Segment CE and segment CD. Notice we have the segment symbol above, not line symbol. Segment CE and CD are part of line L. That's true. The intersection of plane M and plane P is ED. No, that's false. The intersection of plane M and plane P is AB. That's true. Line AB and line L intersect. That's true. They intersect at point C. Then you have ray CA and ray CD intersect at point E. No, that's false. Then you have segment AF and segment CD intersect at point E. No, that's false too. Okay, well that's it for the lesson. If you need any help working through any of these problems, let me know. I have real objects for you to look at. So if you're having trouble understanding how to solve these problems based on this two-dimensional diagram, I have actual three-dimensional objects that'll help you see it better. Okay? So if you have any questions, always make sure to ask for help. Begin the assignment.